We will continue doing integration by parts, more integration by parts. I only showed you some simple ones, and today we're going to do some more complicated ones. So first example is when you have integral of x cubed ln of x dx. Now, when you see this question, you should know that this question requires integration by parts. Why?
Because of x to the third power.
Okay. What else? Anyone else?
There's a product. There's a product.
There's a product. There's a product of two functions, okay? It's not just that there's x cubed, but there's x cubed and log of x multiplied. It's actually the multiplication that's important. Now, then you might ask, well, for any products, do you always use integration by parts? And the answer is no, because here's an example. Integral of x times sine x squared. For this one, what should you use?
Use u sub.
You have to use u substitution. Okay? You can't do by integration by parts. Now, why is this a u substitution question, whereas this is an integration by parts question? Well, over here, this one is kind of tied to this one. If you differentiate x squared, what do you get? You get 2x, right? And 2x is a multiple of x. So you can really think of this as like part of the artifact of the chain rule. When you undo the chain rule, this x will vanish away. That's why this is a u substitution, whereas this one doesn't have such a structure. You don't have like an inside function whose derivative is outside. It doesn't have that structure. So this is an integration by parts question, whereas this is a u substitution question. Now you may further ask, why not integration by parts? What goes wrong if you try to use integration by parts? And that's a valid question that you should think about. Okay, so if you actually try to integrate this one, because integration by parts means you only integrate one of them, right? And you differentiate the other one, right? So if you try to integrate the sine, you end up with this question: what will be the antiderivative of sine x squared? And unfortunately, this is an integration question which doesn't have an answer. And that's a stark difference between a derivative question and an integration question. Okay? For derivatives, any function you write using the basic sine, cosine, tangent, exponential, the transcendental functions that we know, or even the inverse or fraction, polynomial, any mix of these, whatever you write, you can always differentiate them, and the derivative is expressed by these basic functions. Okay? On the other hand, when you do the integral, the antiderivative of this function cannot be written in terms of basic functions, no matter how you combine them, mix them, add them, subtract them, compose them. It's not possible. Now, if you're really curious, do you know wolframalpha.com?
What? Yeah.
Yeah, it's a website where you can put any math questions. It tells you the answer, right? So it's a good way to check if your work is correct. So when you've done your homework and you're not sure if your answer is correct, then you can use that, okay? And you can take this to wolframalpha.com. You integrate sine x squared. You type in integrate sine x squared by x, enter. And then what it's going to spit out is a bunch of functions that you've never seen before. And the reason is, to define this function, you can't express it using the basic functions that we know. So it defines additional functions to express the antiderivative. So because we didn't learn those functions, for us, it's as if this integral doesn't exist. Okay? We can't express this. I mean, you can define a function, antiderivative of this, up to plus c. But that function cannot be expressed by basic functions. Okay, so that's what goes wrong. Okay? All right, so I spent too much time in introduction. Now let's actually try to do the integral. When you try to do the integral, now you see another problem here. When you try to integrate log of x, what is the integral of log of x? ln x? Does anyone know? What's the antiderivative of ln of x?
1 over x.
1 over x is the derivative. It's not the antiderivative. In fact, we've never learned what the antiderivative of ln of x is.
Oh, wait, is it like e or something? Don't you feel like?
It's rather complicated. We'll get there later, okay? Yeah, it's I don't want to discuss it right now, okay? But what we do know is that this is something that you don't want to actually do. So here, usually when we have a polynomial times a transcendental function, we always integrated the transcendental function and differentiate the polynomial. That's how we apply the integration by parts, right? But today it's going to be a little different. We will instead be integrating the polynomial and differentiate the ln of x. Let's see what happens if we do that. So if we integrate x cubed, how do you integrate? You add 1 to the exponent, right? 3 plus 1 is 4, and you put the reciprocal in front. Then minus. Now, what is integration by parts? The one that you integrated already, this is integrated, right? That goes inside the integral unchanged. Yeah, you can also use uv minus v du. Voodoo. It's just too time consuming for me, so I just write it like this. Okay. And then the other one that you didn't do anything to, what happens? What do?
Integrate.
You have to, no, you don't integrate, you differentiate.
1 over.
So the one that you did not integrate must be differentiated, and it goes inside the integral sign. And that we know. The derivative of ln of x is 1 over x. Right? And then x to the 4th divided by x is? What is x to the 4th divided by x? X to the 3rd. And you can pull the 1/4 out, so you're integrating x to the 3rd dx, so that it's 1/4 x to the 4th ln of x minus 1/4. Again, x to the 3rd integrates by adding 1, x to the 4th, and putting the reciprocal in front, plus c. So the final answer is 1/4 x to the 4th ln of x minus 1 over 16 x to the 4th plus c. Now, final words about this. There's one more comment I want to make. So, for integration by parts, you need to settle 2 questions. Okay, so number 1. Is this integration by parts or USO? That was the discussion that we had early on, okay? But the second question is, which one do we integrate? And for this one, we have to remember mnemonic. And the mnemonic goes like this. LIATE. LIATE. So this means L means logs. I means inverse trigs. A means algebraic. T means trigs. E means exponential. And whatever that falls on the right side is the integral, the one that you integrate. On this side, you do the derivative. So for this example, you have x cubed multiplied with ln of x, right? X cubed is what kind of function is it? Is it log? No. Is it inverse trig? No. X cubed should be algebraic, because algebraic means exponentials, x to some power polynomials that are algebraic, rational functions, or any addition, subtraction, multiplication, division of polynomials. That's algebraic. Okay. And trig is sine or cosine, exponential is e to some power. So we see that because ln of x, this one is logarithmic, and x cubed is algebraic, and a is on the right side of the LIATE than the L. You see that a is the one that must be integrated. That's why we're integrating x cubed. And we're differentiating ln x. That's what's happening. So that's a very important thing to remember. So two questions must be settled for integration by parts. Is it integration by parts, or is it U sub? And which one should we integrate? Those are the two.